Hello everyone. So today we'll be going through the advanced TDL concept of variable framework. And this session on variable framework will be broken down into two sessions. The session 1 will consist of the theoretical aspect of variable, covering the concept of variable, its types and how you declare and scope the variable. The second part will consist of how you manipulate these variables and how you retrieve the values from them. So let's quickly go through the topics covered in this variable framework as the whole. So in the variable framework, we will be going through the concept of variables first, and then the types of variables, where there are 4 types, and then we will go through the usage of variables, where we will be seeing the definitions and attributes of variables, and we will be seeing how to declare and scope it. So till here, all these concepts will be covered in the session 1, and the variable manipulation and retrieval methodologies will be taken up in the session 2. So now let's start the session 1 with the concept of variables. So variables, if you see a general definition, it is something which doesn't have a constant value, or which is not consistent, or which is something which is liable to change. So this is basic property of variable. So if you see variables in TDL, so these are the entities which can hold values during the execution of the program, and these are the ones which will help to control the behavior of the reports and its contents. So these variables will assume different values during the execution of programs, and these will affect the behavior of your reports. So a classic example would be when you open a daybook and you change the dates from date and to date, and based on that the content of the daybook changes. So there the variables sv from date and sv to date gets affected, and because of that the behavior of the daybook also gets affected. So then we have the concept of how you create a variable and initialize it, and how you change the values of the variable in due course. So we'll be seeing how we create and initialize the values in session 1, and the manipulating part and changing the value of the variables during program execution, we'll be seeing it in the session 2. So the last point in the variables is the very important point, where it says variables are context free structures which do not require any specific object context for manipulation. So variables are not bound to a specific object. Like you would have seen in a UDF that when you need to specify a UDF, you need to specify in a particular object context. But variables are not like that. So variables are context free structure, that is you need not specify a particular object in which variables have to be stored, and these variables are just declared by its name, and you can just retrieve its value by using the name. So that is what it means in context free structures, that is variables are not bound to any object context. So next we will see what are the types of variables. So based on the values, number of values it can hold, and the data types of variables, we have categorized variables into 4 types. That is, there is simple variable, simple repeat variable, compound variable, and list variable. So we'll go through the simple variables. You would have already been aware of the simple variables, which was already covered in the basic TDL classes. So we'll just go through it once. So what are these simple variables? It just allows the storage of a single value of a single data type. So if you see, this is a syntax which is their variable, and you give variable name, and whatever attribute, you give the attribute name and you give the value for it. So just an example of a default simple variable is an sv current date. So you would have seen in a daybook that when you change F2, when you change the date, that is a sv current date variable which is used, and based on that sv current date, the vouchers which is listing in the daybook also varies. So let us go through the next set of variables, that is the simple repeat variables. So these simple repeat variables are simple variables which can hold method values of multiple objects of a collection based on an implicit index. So this particular concept is usually used in the columnar reports, where you would say add columns. If you remember, you say, and some of the columnar reports, you would say add columns, modify columns, or auto columns. So all these are accomplished by using simple repeat variables, where attribute called repeat is available in the variable definition, and we use it to get this particular type of report. So we'll see in detail about this later. And then we have something called compound variables. So in contrast with the simple variables, where simple variable can hold a single value of a single data type, compound variables will allow us to store values of different data types. So how this is possible is, this is possible by using a attribute called variable, which is a attribute of the definition variable itself. So we'll see how we can write a compound variable, and these sub variables of a compound variable is called member variables, and the compound variable is known as the main variable. So a member variable can be a single instance or a list variable. So we'll see what is a list variable. So the member variable of the main variable, that is the compound variable, can be a single instance, that is the simple variable, or it can also be a list variable, or it can also be a another compound variable. So we'll see how this is obtained. So what they are saying is, a compound variable can have simple variable or compound variable or list variable also. So if a compound variable has another compound variable, so that particular member compound variable will have sub members also. So in that way, there is a particular hierarchy that will happen in the compound variable. So next we have a concept of list variable. So we saw a simple variable which has single value of, it stores single value of a single data type, and compound variable is something that stores values of different data types, and list variable is something that can have a list of instances. This simple variable and compound variable has a single instance, but a list variable is something that has array of instances, that is a list of instances. So a variable at the declaration time can be either declared as a single instance or as a list. So this is what it means. And list variable can hold one or more variables, which can be either a simple or compound variables, and each of these is called element variables. So the variables which is so a list variable can hold one or more variables, which can be either a simple variable or a compound variable also, and these variables which are under the list variables, they are known as element variables. So and element variables holds value as well as key if specified. So we'll see what is this concept of key when we go through list variable in detail. So we already told that list variable can contain one or more variables of simple variables of type simple variables or compound variables. So if a simple variable, so if the list variable contains a list of simple variables, then it is known as simple list variables, and if the list variable contains the list of compound variables, this is known as compound list variable. So let's just read the definition. Simple list variable. Simple variable can be declared as a list, and simple list variables can hold multiple values of single data type. So a simple list variable can hold multiple values of single data types. A simple variable holds single value of single data type, whereas simple list variable holds multiple values of single data type. So that is the difference. Now we'll see what is a compound list variable. Compound list variable can be declared as a list also, and compound list variables can hold multiple values of different data types. So we know that compound variable can hold values of different data types, and compound list variable holds multiple values of different data types. So this is compound list variable. So next we will go through, just quickly we will go through in developer just an example of all these types of variables. So I already told simple variable, this is an simple var. Variable simple var is an example of simple variable, and simple repeat I told. So how do you accomplish a simple repeat variable? You have an attribute called repeat in variable definition, and using that you make a simple variable, simple repeat variable. We'll see the conceptual we'll get the conceptual knowledge of this a little later. And then we have something called compound variable. So we already told compound variable we can compound variable can store values of different data types. So a variable, I have declared a variable called compound variable, and this compound variable has variables of different data types. So I have in compound variable a variable called empname, which is of type string, and we have one more variable called empage, which is of type number. So this is a compound variable. And we have something we already told, a variable called a list variable. So what is a list variable? A list variable is something that can store multiple values of variables. So a list variable is something that can store multiple values of variables. So here I have made a list variable of compound variable. So now I'll have a list of compound variables. So we'll see the concept of list variable also later. So now let's go back to the presentation. So we have variable definition and attributes. We'll go through variable definition and attributes. A variable definition is similar to any other definition, like you had already gone through the definition, report, part, line and everything. So how do you start and end a definition? You open square bracket, you write the definition type, then colon, you write the name of the definition, and you close the square bracket. And it's the same thing that is used for variable also. We open square bracket, we write a variable. So here the definition type is variable, and is2 will give a variable name, that is a user name, user defined name. And then we have attribute and value pair. So we give the attribute type, we mention it, and we give a value to that attribute. So this is how the syntax of variable works. So next we will see the attributes of variable one by one. So I'll take you through that with the help of the developer so that we can understand easily. So we have already seen this. So we will modify the same file to understand better. So we have something called variable. So we already know open square bracket, variable, and we write the variable names, close square bracket. So now we have something called type. What is the attribute type of the variable? So it just says what is the data type of the variable. What is that data type of variable what is the data type of the data that is to be stored in the variable? So here we have all the data types that is available in Tally, like the string, number, amount, time, date and everything. So you can specify a date. So you can specify a data type here with the help of type attribute. So we'll say type, and if you want to see what are the available attribute values for type, you can just say control space, and you have these are the values that is available for type. So now we will say this is of type string. So now there is something called default. We have an attribute called default of variable. So this is the attribute that is help us in giving a default value for the variable, that is the initial value to the variable. So we can give some initial value to the variable. And now after default we have two major concepts or two major attributes of variable that is very useful. So that is, one is called persistent and one is called volatile. So what we will do is we will go through each of these definitions one by one. So before going through, first we will take up volatile attribute. So if you go to volatile attribute, before going to the explanation of volatile attribute, I'll just show a functionality in default Tally which is accomplished by using the volatile nature of the variable. So we'll go to Tally and we'll go to the trial balance. So here if you see, so this is how my trial balance in this company looks. Now what I'll do is, here I have something called group. So now I'll go here and I'll specify some group. So I'll choose current assets. So now if you see, now I have chosen current assets. So just taking you through what happens when you choose it is, when I tell group and when I tell current assets, there is a variable called group name in Tally. So that group name will get the value of current assets inside it. Okay, so now the group name variable has the value current assets inside it. Now what I'll do is, now I'll drill down from here and I'll go to the detailed report. Now I have gone through the detailed report. Now what I'll do is, I'll again go to F4 and I'll change the group name again. So I'll change it to say sales accounts. So now what will happen, my variable group name will now consist of the value sales accounts. So this is done. So now what I'll do, so this is so first what did I do, I had my trial balance of all the groups which is listed out. First I selected the group current assets, then two groups were listed under it, that is the cash in hand and bank accounts. I drilled down from bank accounts and then I got all the bank details. Then what did I do, I again went to F4, I changed the group to sales accounts. So first when I changed the group to current assets, then next I changed the group to sales accounts. So now group name has sales accounts. So now let us see what happens when I go back to the previous report. So now let us see what happens when we go back to the previous report. So now we are aware that the group name has sales accounts. I'll go back to the previous report. But here we see that the details of sales accounts is not there, but the details of current assets is there. So how does this happen? So this happens with the help of the property of variable called volatile. That is, if you see in this report, my group name variable had current assets, and when I drill down in that report, my group name had sales accounts. So when I tell my variable to be volatile, what happens is these variable values become specific to that report. So when I come back from the second report to the first report, whatever value I had selected for group name in the first report will be applicable. So let us just go through. Let us just go through the presentation and see what they have got to tell about the So we already saw attribute type. So the attribute determines the type of the value that will be held by the variable. All the data types supported by TDL, that is string, number, date, etc. can be specified here. And in the absence of this attribute, a variable is of defaulted to type string. So then we saw the default attribute, that is the default value of the variables can be specified during definition using default attribute. So this is the initial value which is assigned to the variable when it is declared or instantiation. When you have declared the variable, whatever default value with the default attribute, whatever value you specify will be the initial value to it. This also we saw. Then next we saw the volatile. So volatile attribute in variable definition. Okay, this volatile attribute accepts logical value, and by default the volatile attribute of every variable will be yes. So if the volatile attribute in variable definition is set to yes, then variable is capable of retaining previous values from the caller scope. So we saw that. So in cases where the volatile attribute in the variable definition is set to yes, the variable is capable of retaining multiple values, that is its original value with its subsequent values are stored as stack. So we saw that when we opened the trial balance, we changed the group name to current assets, and then we went and changed the group name in the next drill down report to sales accounts. So what happens is these values are stored in a stack. So when I go back from the second report to the first report, from the stack, the value of the value for that particular report is taken. So that will be the current assets for my report 1 and the sales accounts for my report 2. So we'll just see an example, that is in cases where a new report R2 is initiated using a volatile variable V from the current report R1, the current value of the volatile variable will be saved as in a stack, and the variable can assume a new value in the new report R2. Once the previous report R1 is returned back from the report R2, the previous value of the variable will be restored. So we saw the same thing. So when we went, our R2 report is the drill down report from the bank accounts which we did. So R1 report will be the trial balance report, the first report. When we open trial balance, whatever we see, let's take it as R1 report. And the report which we next opened was the drill down from bank accounts, and that will be the R2 report. So in the R1 report, we opened the group name, we changed the group name to current assets. So my group name has now the value current assets. Now in the R2 report, which was initiated from the R1 report, the value of my variable group name, I changed it to sales accounts. So now what happens is the previous value of this group name is nothing but the current assets, and that is stored in a stack. So once I move from R2 to R1, that is that the drill down report to the previous report, what happens? The value of the variable group name is restored from the stack. That is the value of the variable group name, which is the current assets, is restored, and now my report will show the details of the current assets itself. So this property of variable, if we want to use, we specify volatile. So we give the variable name, we specify what is the type, and we say volatile yes for the variable. So by default, even if you don't specify volatile in any variable, by default volatile is yes for any variable. You can set it to no by specifying volatile attribute for the variable. So next concept we will see is the persistent concept. So now let us go through the another attribute of variable, that is the attribute persistent. So the attribute decides the retention periodicity of the variable, that is until then it would retain the value of that variable, whether it should retain it till application termination or after application termination as well. That is, by default, when you don't have this persistent, what happens is the value of the variable is lost once you terminate the application. So if you want the value of the variable to be retained even after the coming out of tally, then you will have to say persistent yes for that variable. The classic example for this would be the backup path which you would give in the tally. The path, whatever path you give, is stored in a variable, and the variable is of type and the variable is persistent. That is, even after you come out of tally and again you open the tally application, the particular path that you had selected, that you had last selected previously, will be retained, and that will be shown in the backup path. And also your select company path, all these are stored in variables which are persistent in nature. So when you say persistent yes, the value of the variable, the last value of the variable before terminating the application will be retained, and that will be available when you open tally application again. So when you say persistent no, then the value of that variable is lost once you come out of the application. So setting the attribute persistent to yes means that the value saved during the last application session will be retained permanently in the system. When the next session of tally is started, it will take its initial value from the value saved in the previous session. So how does this happen is, this value of the variable which is persistent in nature will be saved in a file called tallysave.cfg. So in this file, all the value of this persistent variables is saved, and once you open the tally application again, the values for these variables is restored from that particular file. So this is how we can it's possible to retain the previously entered value before exiting the application and restoring it back into the variables once the tally application opens. And one more important point is, only variables which is declared as system scope can be persistent. So we'll come to what is the scope. So you must be already aware of what is a system variable, report level variable, and everything. So only the system variables can be persistent. So as I already gave an example of the backup path, so there is a variable, we use a default variable called CSV backup path, and this is of a type persistent yes. So what happens, I'll give a backup path in my tally application, then I'll exit from the tally application, and again when I enter reopen the tally application, the backup path which I had previously given in the previous session will be retained, and it will be restored into my SV backup path variable. So I'll get the backup path which I had previously entered. So this is the usefulness of the persistent variable. So now we already saw something about the repeat attribute of the variable. So we saw that this is majorly used in columnar report. So we'll see attribute repeat for a variable is used for columnar reports. Multiple values are stored in the variable based on an implicit index. Method value of each object of collection will be picked up and stored in the variable based on the implicit index. So let's see conceptually how this is possible. So how do we write it? We have variable name. So we have variable, we get variable name, and we have repeat attribute. We say repeat, and we give a collection name, and we give a method name. Method name is optional. If you want the variable to repeat over a method from the collection, then we can give the name. And in case if you have not specified a method name, then the variable name is taken as a method name. So let's see, variable name is the name of the variable. Collection name can be an expression which evaluates to a collection name. Method name is the name of the method whose value needs to be picked up from each object of the collection. If not specified, variable name is considered as the method name. So there is an example called variable p name, and here they have told repeat over hash DSP repeat collection. So we know that to access value of a variable we use the modifier hash. So in this DSP repeat collection variable, there is a this DSP repeat collection variable consists of the value which is a collection name, and now I say variable p name repeat over the value that is consisted inside DSP repeat collection. So let's just go through this how it is done. So let us take a simple example, default example. So we'll see we have this is a columnar report. Now if you want to set auto columns, you select, you say daily, and you see that the columns are repeating. So I said daily, so for every day a column is inserted. So this is a columnar report, and this is accomplished by using the repeat behavior of the variable. So the variable, so there is a variable called SV from day, which is repeated over the collection of, there is a variable called SV from date, which is SV from date and to date, and this is repeated over the so here the variable is repeated over the collection periodicity, and with the help of which the columns are added. So we'll just give an example, we'll see an example of this columnar repeat behavior of variable. So you must be always already aware of how to write a columnar report, or auto columnar report, automatic auto columnar report. So let us just see the behavior of the variable, repeat attribute of the variable, by seeing a automatic auto columnar report. So I have already written the program for it. Let us just go through this program. So what is this? I have a report here. So what I want in the report is, in my report I want all the lines to repeat over the stock items, and that is vertically I need stock item details, and horizontally I need the party ledger details. So the party ledger details I want it from the vouchers. So this is my this is the need of my report. Now I'll see how I accomplish this. So first we have a report, we have a form, we have a part, and we have a line. So we already told that we want the line to repeat over the stock item. So I have a stock item collection and I'm repeating over it. So my line is repeating over the stock item collection, and in that line there is a field which shows the name of the stock item. So now the vertical repetition is done. Now I need the horizontal repetition, and horizontally, so since this is a automatic auto columnar report, in this already when the report is opened, already the columns are already set. So how do we set it? We specify an attribute in report level saying set auto column to yes, and then we specify variable in the report level, that is do set auto column, and we set that variable to yes. So this is the first thing which we do. And then now we will use the repeat attribute of the variable. So now what I have is, I have a variable called p name, and I am repeating over DSP repeat collection, a variable DSP repeat collection. So let's see what does this variable consist of. So if you see my report, I have set this value to this DSP repeat collection to CBFK party. So we already know that when I am repeating in my variable, when I am repeating when I am using the attribute repeat, I repeat over a collection. So this whatever value I'm giving in DSP repeat collection must be a collection name. So I must have a collection called CFBK party. So I have a collection called CFBK party. So which is nothing but this collection has a source collection which is of collection which is of type voucher, and I walk into inventory entries and I do an aggregation over the party ledger name. So now if you see, we already said that if I have not specified a method, we already saw that if I have not specified a method in the repeat attribute, then it takes the variable name as the method name. So since I have not specified any method name in my variable repeat attribute, I'll have to give the same name as the variable name. So I have written by p name party ledger name. So I have a collection of inventory entries where I have done an aggregation by the party ledger name. So now what we need to do is we need a horizontal repetition over these party ledger names. So how do we get it? So first step is we have done a repeat over the collection which has these party ledger names. So next, how do we link it with the report? So we have to next give in the report level repeat whichever variable that is repeating over the collection will be given the report level attribute we mentioned. It is the will give repeat and we give the variable name. And now the next step which we do is, so we know that we need a horizontal repetition. So for horizontal repetition, we know that we need to repeat the field. So I go to my line where I need to give the details, and here I am repeating the field. So first what I did, I gave a repeat attribute in my variable, then I specified a repeat attribute of the end of the report saying which is that variable which is going to give me the columns, and next is I am repeating the fields. So the number of values that this variable p name consists, so many number of columns will be added. So next in the field whichever is repeating over the collection, the field whichever is repeating, so there I set the value in the field and I want that fields to give the name of the party ledger name. Let's see what is the output of this particular. So we have this, and if you see here, vertically the stock items are repeating, and if you see the title, I have repeated the party ledger name, and that is horizontally I have repeated the party ledger name. So how do I get these values? First is I have repeated the. So how do I get these values? How did I get these values in the titles? That is first is main important. So how this value is got is, so if we see horizontally, we see that the party ledger name is getting repeated if you see the title. So this is accomplished by using the repeat attribute in the variable level. So what we did in the variable level, we repeated over the collection which has these party ledger name details, and we again specified a repeat attribute in the report saying this is the variable which is repeating, and then in the line level we wrote repeat the field, and in the field level we set the field to the variable that is repeating. So this is how we get the information. This is how the repeat attribute of variable is used. So next attribute which we will be going through is the attribute list variable of the variable. So we already saw what is a list variable. List variable is a variable that can store multiple values of variables of either simple or compound in nature. So we can use list variable attribute also inside a variable. So we specify list variable, we specify the variable name, and we give a data type and value which are optional. We'll see this is called as inline declaration. We'll see what is the inline declaration later. So if you see this example, there is a variable called CLV_emp, and by seeing itself you can say that this CLV_emp is a compound variable. And in this compound variable, why is it a compound variable? Because it is storing values of different data types. So this compound variable has a variable of type string, one variable of type number, one variable of type amount, and this also has a list variable called relatives, a list variable called city. So the first list variable city is a list variable which is a list of simple variables which is of type string, and it is initiated to a default value 3. And there is one more list variable, relatives, and this relatives is in turn a compound variable, so which has a name, age, and relation and salary. So this is how you make this is how a hierarchy is built. There is a compound variable which consists of a list variable relatives, and list variable in turn consists of variables of type string, number, string, and amount. So next, so we saw the concept of these compound variable, that a compound variable can consist of set of variables inside it. So this is somehow similar to a concept of objects also, because objects has methods and collections in turn a group of objects, and so like that hierarchy is there. In the same way, we saw that in compound variable also we can build a hierarchy. So we will just see a comparison between that. So we have object and compound variable. So we see that object can have methods, whereas compound variable can have simple variable as its member. So we'll just see an example. So it says compound variable can have simple variable as its member. So we saw that there is a So here we see that there is a compound variable CLV_emp, and we saw that in the table it says can have simple variable as its member. So a simple variable is variable name. Name is a simple variable. So the compound variable has a simple variable as member. So you can just relate it to a method of an object. And here it says this can have repeated methods, that is a simple collection. Whereas compound variable can have simple list variable as its member. So we have here list variable city is a simple list variable. Why is it a simple list variable? Because it can store the list variable city stores different values of same data type string. That's why it is a simple list variable. So the simple list variable is comparable to the simple collection of an object. Now we have the object can have collections, that is can have compound collections. In the same way, compound variable can have compound list variable. So if you see here in CLV_emp we have compound list variable, which is a compound list variable. Compound list variable is the relatives. Why is it a compound list variable? Because it is a list variable which consists of which stores different values of different data types. So if you see relatives, so if you see relatives list variable, we see that relatives is a compound variable which has different data types. So the list variable which is declared using relatives compound variable is a compound list variable. So this compound list variable is comparable to the compound collection of an object. So we have one more comparison: cannot have objects. An object cannot have objects under it directly, whereas compound variable can have compound variable as its member. So now comparison. So with an example, we already saw the comparison. So we will just go with an example. We will just see how we can draw comparisons between the data object and also compound variable. So there is an example, CLVM. So this is in compound variable, and here there are 4 variables: name, designation, age and salary, which are simple variables, and we have a list variable contact numbers, which is a simple list variable, and we have a list variable called relatives. So let us just see how this relatives is defined. Okay, so the relatives is a compound variable, so the list variable relatives will be a compound list variable. Then we have one more variable in the compound variable CLVM, which is the contact address. So if we see the variable contact address, we see that it is a compound variable. So there is a compound variable contact address under another compound variable, which is CLVM. So we'll just draw a comparison between object voucher and this particular example of CLVM. So we see that in object voucher is having methods directly under it as date, voucher number, narration, etc. So if you go through the Tally Developer 9 and if you open the schema of voucher, you will see the different methods, the collections under it and everything. So if you see, the voucher has direct methods under it, that is the date, the voucher number, narration, etc. In the same way, CLVM, we saw there were four simple variables. So in the same way, CLVM has 4 simple variables directly under it. So next comparison is voucher is having a repeated method basic buyer collection, which is a simple collection. So simple collection is the group of object of. So voucher is having the repeated method basic buyer collection, a simple collection. So in the same way, CLVM has a simple list variable contact numbers. So if you see, the CLVM has list variable contact numbers, which is a simple list variable. In the same way, if you see object voucher, you can see that there is a compound collection, that is, you can call inventory entries as a compound collection under it. And the same way, CLVM has compound list variable, which is relatives. And the next one, we say voucher object cannot have an object directly under it, but compound CLVM can have another compound variable under it. So this is the compound variable, that is the contact address, which is the compound variable under it. So this is just to draw comparison between data object and compound variable. So let's see the variable declaration and scope. So here we see the declaring a variable. What is declaring the variable? So we already know what is defining a variable. Defining the variable, which is already you saw, where we open square bracket variable, we give the variable name, we give the type, default, persistent, volatile and everything. That is called a defining a variable. That is giving a shape to that variable. And now what we do is, we now use that variable, or we can say that we link it to some scope. So that is known as declaring a variable. So we do it using variable colon variable name, or there are different ways in which you can declare a variable. So that is called a declaration. So next we will be seeing the concept of list variable. So we already know what is the definition of a list variable. So the difference between a list variable and a normal variable is that the normal variable have only one instance, whereas list variable has a list of instances. So when we see the concept of list variable, we have two concepts to be understood. One is the concept of key, and one more is the concept of index. So before going to this, I'll just show an example uh, which can be used to portray the list variable. So what I have done is, here I have just put down some employee details. So I have employee details. I have 4 employee details, and the details about the employee is the name of the employee, the age, designation, and salary. So what I want to do is, we know that a list variable can hold a list of instances. So what I want to do is, I want to put these list of employee details inside a list variable. So to put these list of employee details to list variable, so we need to understand the key concept and the index concept. So when I'm adding these values to my list variable, so later, and if I want to access these values, so how will I access? So for that, we would need something that will help us to access these variables or manipulate these variables. So that's why we have 2 concepts. One is the key and one more is the index. So let's go to it. So the concept of key. List variables can hold multiple values of variable type using a string based key specification. So what does it say? So we had 4 employee details, right? So when we are adding each employee detail to the list variable, we can add it using a key. So when we are adding 4 employee details, we can have 4 unique keys for the 4 employee details, so that when I am later accessing these values, or when I want to manipulate these values or change these values, I can access these list variables or list these employee details using my key. So list variables can hold multiple values of variable type using a string based key specification. So we'll be seeing it later. So in the next session, when we take up the manipulation part of list variable, we will see how we use a key and we will add the variables. And this key is of type string. By default it is of type string. You can also change the type of the key to any other type, like number or something, if you want some sorting to happen on this key. So this is the concept of key. And TDL programmer has to explicitly specify the key value. Key is unique for all items in the list. That is why key is important. So if you have a unique key for each employee you are adding in the list variable, then next time you when you want to manipulate it, you can use this unique key to manipulate the details. So it is like each of us have an employee number, or each of our people, we have some Aadhaar card type which has we have a unique key associated with that, so that our details can be fetched later by the government. So in the same way, when we are adding details to the list variable, we will add the instances which has a unique key, so that we can operate on it later. So the key needs to be unique for all the elements in the list. So if an element is added with duplicate key, then the existing element will be overwritten. For example, you have employee 1 details, employee 2 details. For employee 1, you have added some key called 001, and for employee 2 also, if you are going to add a key of 001, then what will happen is the first employee details will be overwritten with the second employee details. So it's very important to have a unique key. We can just give an example for it. For example, if I am having these details are something that I want to fill in the list variable. So you can just give, when you're adding, you can give key like E001, E002, E003, or E004. So you are giving a key for each employee detail, that is, you have a key for each list variable instance. So we have next concept. So we have next concept of index. So an element of the list can be accessed via index. Index of an element is the location or position of the variable from the first element in the current sorting order. even if we have specified keys for elements of a list, index is generated internally. So we saw that we have 4 employee details. So these 4 employee details, when you're adding to the list variable, this will be added with the index. That is, when you're adding these 4 variables in the order of your addition, or if in the current sorting order, it will be indexed with 1, 2, 3, 4 in that way. So this is an array of variables will be created, and this index is generated internally. A user need not specify, it will be generated internally. So for example, so we have employee detail, 4 employee details. When I add these employee details to my list variable, and when I'm not sorting in any order, so sorting will be covering it later, when I'm adding in the same order, then the index for each internally generated would be, this will be 1, 2, 3, 4. So an index for each instance of list variable will be generated internally. So then they say that it is always possible to access each element in the list by specifying the index with square bracket in dotted notation syntax. So we'll see what is a dotted notation syntax. So this is the concept of index. So when you see the concept of key, the key is a string. Key is a default type string which is given by the user for each instance of list variable. So if the user wants to give a key, he can give. It is optional. If he doesn't want to give a key, it's okay. So when you're giving a key for instance of list variable, it is very important to see that each key is unique in nature. So if you are giving a duplicate key, then the current instance of what you have added will if you're giving a duplicate key, then there will be overwriting of information. And also the key is default type string, which can be also changed by the user. So next we come to concept of index. So index is a internally generated number. So each element which you're adding to the list variable will have a specific index in the current sorting order. So then we have something called variable path specification. Using dotted notation syntax, how do you access these variables, or how do you go to the variable? So we see that we have a list variable, and inside list variable we have a list of information. So how we can go to each information, we'll see by using the dotted notation syntax. So the syntax here is element variable specification dot member variable specification dot simple member value specification. So we'll see what is element variable specification. So this can be a compound variable or compound list variable. So with the index expression, so this is the index which is generated internally, and then we have member variable specification, that can be a compound variable member or compound list variable member, and with a index. If it is a list variable, then there needs to be a index, because we know that a list variable has a list of information, so you need to tell the system which position of the which is that instance of list variable you are accessing. Then we have simple member value specification, so refers to the name of the simple member in the specified path. Then we have the index expression. This can be expression that evaluates to a number. Suffixing a variable with index refers to an element variable. So that is what I was speaking about. So if you're writing a compound list variable, so we need to tell which is that element of the list variable we are accessing. So this index can be either positive or negative. If you are giving 1, 2, 3 for positive, then it means it is in the, so it means it is in the top to bottom, it travels from the top to bottom. If you are giving a negative index, it denotes that you're traversing from the bottom to top. So there is an example here. So there is a compound list variable called CLV-emp, and there a simple variable inside the compound list variable. There is a simple variable called name. So how do you access it? We have accessing using a index. We are accessing the first instance of compound list variable CLV-emp. That is the name of the first instance of CLV-emp is accessed here. And in the same way, if you see the second example, so there is the CLV-emp is a compound list variable. Inside the CLV-emp compound list variable, there is one more list variable, that is relatives, and then inside relatives there is a simple variable called age. So I am accessing the age of the first relative of the second compound variable CLV-emp. So this is how you give a dotted notation, that is you follow the hierarchy. Next we have the scope specification in variable dotted syntax. So the dotted syntax for variables is now enhanced to allow specification of scope. So how do you access variables in different scope from the current scope is what we will see now. So we have the concept, you would have already gone through this concept in objects and collection. So we have concept of double dot, triple dot, and open bracket scope, square closed bracket dot, which denotes the system scope. So we have we can use the same concept, similar concept in variables also. So double dot means it denotes the owner scope, triple dot means it denotes the owner's scope, and if you give 4 dots it's owner's scope, so and so on. And if you give brackets dot, then it means it is a system scope. So the syntax is definition type. So open bracket, close bracket, definition type, comma, and definition name expression can be used to specify an absolute scope specification. So definition type is the name of definition such as report, function, etc. And definition name expression can be an expression which evaluates to a definition name. So for example, you are in a field level and you want to access the value of a variable from a function. So how you can do it? So all those things we will see here. So we have examples. So there is a variable scope where in a system scope, in the system scope, and we will see so here is an example where there is a variable called scopeware, which is a variable name called scopeware, which is in a system scope, and this variable is also present in the function scope. So now I have a report, and I have a report in which there is a variable again which is scopeware, that is the same name, and this is in the report scope. So I have a variable of same name, one is scope to system, one is scope to function, and one is scope to report. So now in my field, if I want to access this variable, the value of this variable from function, from system, as well as from report, how do I do it? So this we can accomplish by using the dotted syntax and by using the scope specification. So now I have a field in which I have a report in which there is a field. Now I just say hash scopeware. So since I'm in a report context, obviously I'll get the value of the scopeware from the report scope. That is, in the report scope, the value is set to report scope, and this is the value I'll be getting in the field. So now what if I want to access the value from a system scope? So what do? I write hash brackets dot scopeware. So when you give brackets dot, it means that you are accessing value from a system scope. So now I'll get the value in this scope spec system. I'll get the value from the system scope. Now, so we saw this report, right? So if this report is being called, if you see in this function, In this function again the scope var is there, and this is in this function the variable is set to function scope, and this function displays the report scope spec, which is our report. So now in the field of this report, when I write hash hash dot scope var, it will go to my owner's scope. So who is my owner? The owner of the report is the caller of the report. The caller of the report is function. So whatever is the value of scope var in my function, that particular value will be available in the field. So this is the scope specification. And also you can give a particular function from where you want to fetch the values. For example, here we are giving function comma the function name dot scope var. Even then you will get the value of scope var from the function. So let us see how we can do this through an example. So here in my example I have a function, and in my function I am using the variable XR variable. So I am setting this XR variable to this is function scope value. So now this XR variable is in the context of my function, so it is in the function scope. So from this function I am displaying a report, and in this report again I am using the variable XR. Again I have declared the variable XR variable, and this variable now is in the report scope, and in the report scope I am setting the variable to this is the report scope value. And this variable I have also scoped it to the system by putting it in the system colon variable, and I have set it to a default value of this is system scope value. So we have the same named variable declared at three different scopes. One is system, where it is set to this is system scope value. One is function, where it is set to this is function scope value, and from this function I am calling a report in which also I have declared the variable which is set to this is report scope value. So now we will see in the fields how I can access these three different values by just being in the field. So now I have the first field. So in this what I have done, I have just accessed it using, I have just told a hash hash XR variable. So here what it means is already my field is in the report scope. So obviously it will take, in this field I'll get the value of XR variable from the report scope value. Now I have the next field where I have written set as hash hash dot XR variable. So when I am writing dot, it means it goes to my owner's context, or you can say my caller's context, or you can say my parent scope. So which is my parent? So the parent of the report is the caller of the report. So caller of the report in this case is the function. So in the function, whatever is the value set for XR variable will be available in this field. So then we have one more is XR versus system. We have the third field where I have set hash hash brackets dot XR variable. So what does brackets dot mean? It means that it goes to the system scope. So whatever is the value set for XR variable in the system scope, that will be available in this field. So we have the third field where this is the fourth field where we have an absolute specification given. That is, we are specifying from where I want the XR variable. So I have specified hash hash from the report. From which definition type? From the report. Get me the report from the value of XR variable from the report. So which is the report which is in this context of this field? So that is the report in which the field is there. So from that context the value of XR variable will be obtained. So let us see what is the output of this code. So now if you see, we have in the first field we had set it to hash hash the variable name. So that will refer the value from the current scope. The current scope of the field was the report scope. So from there the value was obtained. In the next field we got the value from hash dot dot the variable name, so that becomes the owner scope or the parent scope. The parent of the report was the function, because the function is the one which called the report. So from there we got the value. This is function scope value. So the next field, in the next field we had set hash brackets dot the variable name. So when you say hash brackets dot, it means you are going to the system scope. So here we see that we have got the value from the system scope. So the next was the absolute specification, where we mentioned that I want the value from the report. When I say hash report, and I have not given any report name here, but internally it knows that in whichever report context the field is, from there I need to get the value of the variable. So it says this is report scope value. So now we can just see, when we wrote hash report, it got to know that it had to fetch the value from the report which is in the context. So we can just change it to hash function and see if it will get the value from the function which is in the scope of the field. It will get from the function in which the field is in. So now if you see, the value we have got it from the function. So we didn't even give from which function the value should be got. So internally it gets to know that since the function which called there was a function which called the report, so in that context itself it will evaluate the value of the variable. So this is how you can, with the help of the dotted notation as well as with the help of scope specification, you can retrieve the value of variable from different scopes. So let us just have a small recap of what we learned in the first session of the variable framework. So we started with what is a variable, and then we went to the types of variable. We saw that we have simple variable, simple repeat variable, compound variable and list variable. So these are the 4 types of variables which are available in TDL. Then we saw what is simple variable. So simple variable is something that allows storage of a single value of a specified data type. So you define the variable saying variable opening and closing the square bracket and variable colon, give the variable name, and then you give the attributes. So that is simple variables. Simple repeat variables are those simple variables that can hold method values of multiple objects of a collection based on an implicit index. And this particular simple repeat variable, this concept is used in columnar reports where lines should be repeated vertically and fields are repeated horizontally. Then we went to compound variables. In contrary with the simple variables, compound variables can store values of different data type. So this is achieved by making the variable itself compound by using variable attribute of the variable definition. So this member variable, so whatever the variables of compound variables are known as member variables, and the variable is known as the main variable. So the subvariables are known as member variables of the main variable. And these member variables can be either single instance or of list variable type. So then we went to list variable. So list variable, this can hold multiple values of multiple data types. So that is in simple variable, we saw that it can hold only one instance of value, simple and compound variable. So whereas this list variable can hold multiple instances, that is a list of values. So if those values are of single data type, then there are simple variables. If it is of multiple data types, then they are compound list variables. Then we went to variable definition and attributes. So attributes you give in the variable definition, attributes are given in attribute value pair. So first we went to type attribute, where you specify what is the data type of value that will be stored in that variable, and then default attribute will help to give an initial value to the variable. And then volatile attribute, if you set the volatile if you set the attribute volatile to yes in the variable, then that helps to save the values of the variables in the stack, and then the variable is capable of retaining previous values from the caller scope. So then we went to the attribute persistent, which decides the retention periodicity of the value of the variable. So that is whether if you set it as yes, then even after termination of the application, the value of the variable can be will be still available in the file tally.save.cfg. If it is set to no, then the value will be lost at the application termination. So if the persistent attribute of the variable is set to yes, then even after application closure, if you open the application again, those variables value will be initialized to the last value that was stored in the variable before exiting the Tally application. So then we went to the attribute repeat. So with the help of attribute repeat, the variable becomes simple repeat variable, and it can be used for columnar reports. So multiple values are stored in the variable based on an implicit index. And then the method value of each object of the collection will be picked up and stored in the variable based on this implicit index. And then we went on to the variable attribute of variable definition, with the help of which you can define the simple or compound variable. And then we have list variable attribute of variable attribute. So if you want to make a list variable as a member of the variable definition, then you use the attribute list variable. So then we went on to compare between object and compound variable, where we told that the methods of an object are comparable to the simple variable of the compound variable, and the repeated methods of an object are comparable to simple list variable of the compound variable, and the compound collections, that is the collections of the object, are comparable to the compound list variable of the compound variable. And we saw one difference between object and compound variable, that object cannot have another object under it directly, but compound variable can have one more compound variable under it directly. And we saw that with this particular nature of having variables under variable, you can create a hierarchy of variables. So then we went to the variable declaration and scope. So till now we saw how to define variables. So now we went to the declaration of variables. So you can declare variables in different formats. This is one example of format where you say variable : give the variable name. So when you declare the variable, you need to scope the variable to some level. So what is the scope of variable? The availability of the variable within the definition under which it is declared is called as scope. So wherever you have, in whichever definition you are declaring the variable, so the availability of the value of that variable will be in that definition. So that is called as scope. The lifetime, in short, the lifetime of variable is known as the scope. And variables can be declared. It can have three scopes, that is system, report and function. So we went to the system scope. So when the variables are declared at the system level, its life starts from the application start and ends when the application is terminated. And these values of these variables can be accessed anywhere in the system. So these are some of the ways in which you can declare variable and system scope. And then we went to report scope. So when the variables are declared at report scope, their values, their life will start at the execution of the report, and it will end at the termination of that report. So these are some of the ways in which you can declare variables at the report scope. So we know that only system, so I explained the persistent behavior of the variable. So only these persistent So only the system variables can be persisted in the file tally.save.cfg. We know that. So in case if you want to persist those values of the variables which is at report scope, or you want to persist those system variables which are not persistent in nature into a user defined file, then you can use the action save variable and load variable. So when you say save variable and give a file name and give a list of variables, so those variables will be saved in the user defined file name. So after saving to the file name, you can even load those variables from the file, and the file by default is a .pbf file. So moving on to the function scope. So we can also declare the variables at the function scope, and then when the start of the function variables has the lifetime from the start of the function till the end of the execution of the function. So these function allows a special scope called static, and the initial value to the static variable is set only once, that is in the first call of the function, and in the subsequent calls the variable retains the value from the previous call, and only simple or compound variables can be declared as static, whereas list variables cannot be declared in the static scope. So these are some of the this is how you can declare the variables at the function scope. And then we went on to the inline declaration. So we saw definition and declaration, which are two steps. That is, first you define the variable, and then you declare it in the variable in some scope. So now how it will be if we can combine these both, definition and declaration. So we can combine both definition and declaration using inline declaration format, where while declaring itself you implicitly define the variable also. But when you use inline declaration, that particular variable will have limited behavior. So inline system variables cannot be persisted, because since these have limited behavior, you cannot specify any additional behaviors like persistent, volatile, etc. to these variables. And compound list variables, for this definition is mandatory, they cannot be declared inline. So let's see how you can declare inline variables. So we can declare inline variables by saying variable : give the variable name and its data type and its value. So this is how you can declare inline simple variable at any scope. And in the same way, and you can inline simple variables, you can do inline declaration of multiple variables also, if it is of same type, and if or if it is of same type and having the same initial value. And then we can also declare inline simple list variable. So where you say list variable, give the name of the variable and the data type and its value. So even here you can give multiple list variables also with a separation of comma. So next we went to what is the concept of list variable. So we know that list variable can hold multiple instances of variables, that is a list of variable values. So if it is holding values of a single data type, then we say it is a simple list variable. If it can hold a list of multiple values of multiple data types, then it is called compound list variable. So how these instances can be added to the list variable is with the help of key specification. So there is a concept of key. Using the concept of key, you can give a key to each instance and add these elements to the list variable. And by default, this key is a string type, which can be overridden if you want it for the use of sorting. And this is optional. And then this particular key has to be explicitly given by the TDL programmer. And if an element this particular key needs to be unique, and if this particular key is not maintained as unique. That is, if you are adding an element with a duplicate key, then the existing element with that key will be overwritten with this with the data of the newly added element with the duplicate key. And then we went to concept of index. While you add elements to the list variable, then by default implicitly an index will be assigned to each element in consecutive manner. It is of, that is, a number will be assigned to each element consecutively. So when you add the first element, it will have the index 1, second element will have the index 2, then third element 3. In the same way, all the elements will have its own index consecutively. So with the help of index, you can retrieve the value using square brackets and not dotted notation syntax. So next we saw how we can use variable path specification using dotted notation syntax. So we saw that we can use the syntax element variable specification dot member variable specification dot simple member variable specification. So if the element variable is a compound list variable, then an index should be used. If the member variable is also a list variable, then an index is used, and then we use the simple member value whose value we need to fetch. So we fetch the value of CLV emp, the name of the first element of the compound list variable CLV emp. In the same way, in the second example, we fetch the age of the first relative of the second element of the compound list variable CLV emp. So in this way, you can use variable path, and you can specify the variable path using dotted notation syntax. Then we went to scope specification. So if you are in any scope and you want to access the value of variable in the previous scope or in the owner scope or in the system scope, how you can do it? So you can do it by using double dot, which becomes the owner scope, triple dot becomes owner scope. In the same way, 4 dots becomes owner scope, and so on. And brackets dot denote that you are getting the value from the system scope. And you can also give an absolute scope specification telling report comma the name of the report, or function comma name of the function, and retrieve the value of the variable from that definition type. So this ends the session 1. So next we'll be seeing what is in the session 2.